we will actually extend first the trip logistics example. So now let's say we have three options. One option is to get a warehouse space from the spot market as needed. Another option is that we sign a 3-year lease for a fixed amount of warehouse space, and then the rest we get from the spot market. And then third option is to go for a flexible lease with the minimum charge that allows variable uses of warehouse space up to a limit with additional requirement from a spot market. So we can have a flexible one and also a spot market combination. And our initial situation remains more or less the same. 1,000 square feet required for every 1,000 units of demand. Current demand is 100,000 per year. Uncertainty is demand can go up by 20%, go down by 20%. The probability of going up is 50% and the probability of going down is 50%. It is just 1 minus the opposite. So it's 50%. And the lease price is $1 per square feet per year, and a stock market price is 1.20 per year. But we have some uncertainty with the stock price. That is, the stock price can go up by 10% with the probability of 50% and go down by 10% with the probability of 50% again. And our revenue remains the same, 1.22 per unit of demand, and our K remains the same. The rate of return remains the same. So here is our decision tree. So this is the calculated one. But now let's give a try if we can actually make this figure. And how can we make this? So the things we have to remember is that our starting point is 100,000. And our demand can go up by 20% and go down by 20%, but with a probability of 50%. Okay. And then our lease price remains the same for the upcoming 3 years. It is always $1, but this price here, 1.20, it can go up by 10% or go down by 10% with a probability of 50% for both cases. So this information is the important ones actually to formulate the decision tree. So here, please excuse my handwriting when I'm writing in laptop using this tool. It's not really very good. So anyway, so what we know is we are considering 3 periods, as you can see here, P1, P0, P1 and P2. So we are actually looking into 3 years of cash flow, but we say that we actually make the payments, all the payments are made on the beginning of the year. So that helps us to start from P0, okay? So now, at P0, what do we know? We know that our demand is about 100,000, okay? So demand is 100. And what is our price of, so the lease price is fixed, right? But what is the price of a stock price? So if I call this P, the first one is D and this one I call P, it is 1.20. So that's our initial starting point. But we know that our demand increases by 20% with a probability of 50%. Right? So what will be our 20% increase? That will be 120. So 20% of 100 is 20, and then we add that with 100. So in our next period, actually, our demand is likely to be 120. Okay. But this 120, for this 120, our price can go up by 10%. Price can go down by 10%. So what will be our price if it goes up by 10%? So 10% of 1.2 is 0.12. So if I just add that with 1.2, it will be about 1.32. So the price will be about 1.32. So remember, always the first one I am referring to demand, and the second one I will be always referring to price. Okay, I will not be writing D and P all the time, okay, for simplicity. So now, for this demand, growing demand of 120, our price can go up by 1.32, and also our price can go down by 10%. So that would be, so we again have to consider 120, and our price go down by 20%, and that would be 1.08. So now we deduct 0.12 from 1.20. Okay, so 10% is, yeah, here the 10% is 0.12. So 10% is 0.12. So we add this with 1.2, that is here, and we deduct this from 1.2, that is here. Okay, but now our demand was going up by 20%, but our demand can also go down by 20%. So we consider the up here 120, but if it goes down by 20%, then it will be 80, right? And for 80 demand, again our price can go up by 10% and price can go down by 10%. So it will be the same two values as here, 1.32 and 1.08. So our demand could be 80 and with 1.32, and our demand could be again 80 with 1.08. These lines here, all these lines, they represent the transition period from period 0 to period 1, and they also have some probabilities associated with that. So as both the cases, in this case the probability of going this up, going the demand up or down is 50%. Okay, that is 0.50, and also the probability of this price going up or down is 50%, 0.05. So for the transition periods, we will calculate the probability as 0.5 multiplied with 0.5. So that would be 0.25. So actually in all these transition periods, this is our probability, 0.25. In simple words, this means that the probability of demand going up by 120 and at the same time price is becoming 1.32 has a probability of 0.25. The demand becoming 120 and price becoming 1.08 is 0.25. And similarly, all of them are 25. So you see the total of this is actually again 1. Okay, so the total probability going out from this node is 1. So that's what we have. But then again, the same logic applies for all the nodes here for the next period. Okay, so how to do that? So now our demand can again go up by 20% from 120. So the 20% of 120 is 24. So when our demand goes up, it will be 144. And then when our demand goes down, then it will be 96. Okay, so we will be deducting 24 from 120. So again, from this period, we actually know that the first two will be same in this case, and the second two will be same in this case, because each of them we have to count for different price. Okay, so price once for price increase and once for price decrease. So now again our price can go up by 10%, go down by 10%. So from here 1.32, so the 10% of 1.32 is 0.132. So if I add 0.132 with 1.32, then I will get 1.45. Right? So our price will be then, if it increases, then it will be 1.45. And then if it decreases, then our price will be 1.19. We have to deduct 1.19. We have to deduct point. How much was it that we are deducting? We are deducting 0.132. Okay, so it will be 19, and then the same values will come here, 1.45, because for 96 it can go up, and again for 96 it can go down. But here, just the way I have already formatted this chart is because I know the solution, right? And putting this value here will be much nicer in comparison to putting it here. So what I'm going to do is I'm going to just erase it from here and I will put it back in here. We will have 96 of demand and we will have a price of 1.19. And each of these transition periods again will have the same probability, because the probability of demand going up was 50% and price going up was 50%. So again, all of them, the transition period will have the same probability of 0.25. So now let's try to do it for the next node. So for the next node here, we have now, so I'm going to use another color. Let's say I'm going to use blue. So for this node now, we again have to do the same thing. So what happens when 120 goes up? 120 goes up by 20%, we get 144. So that's why we just link it here, okay? And when the price of 1.08 goes up by 10%, what happens? 1.08 multiplied with 0.1, so it is 0.108 plus 1.08, so it is 1.19. So we exactly have the same values here, so that's why we just connected with this one. What will be the next value? So again 120, it will be like 1.44. It increases by 20%, right? And then this one goes down by 10%. Now we have to deduct 0.11 from this value, and that will result 0.97. So we'll have a value of 0.97 for price here. And then again 120 can go down, and when it goes down by 20%, it will be 96. And when this one goes up by 10%, it will be 119. So we exactly have the value. That's why we just connected here, okay? But then again, when it goes down, it will be 96. And when the price goes down, it will be 0.97, which this combination we don't have already here. So we are making a new one. And here, so 96 with 0.97. So 96 again is our demand, and this is our price for this period. So now let's look into this node. I'm going to use again a different color. Maybe I'm going to use black. So here we have 80. 80 can go up by 20%. So 20% of 80 is actually 16. So when it goes up by 20%, the value will be 96, and which we have here, right? And at the same time, when the price goes up by 10%, it will be this. So 10% of this is 0.13. So when we add it, it is 1.45. And we exactly have the same value here, 1.45. So that's why we just connect this line here, okay? And then our demand, when our demand goes up by 20, and we have to consider when this price goes down by 10%. So when it goes up by 20%, it is 96. We already have it here, and we exactly have the same combination. And when it goes down, we will have 1.19. So we exactly have the same combination here. That's why we didn't create a new circle, new node, and we just connected it here. But now, when our demand goes down by 20%, then it will be 64. 80 minus 16 will be 64, and we don't have 64 here. That's why we are creating a new node. Okay? And we will need two of them, because one for price up and price down. Then, so here, for 64, we will have first the price up from 1.32 by 10%, which will be 1.45, right? Next one would be 1.19 when the price goes down by 0.13, okay? So that's how now we have the 4 values for this node as well, okay? So we have only one more left. Now I'm going to pick yellow for this one. So again, we have a demand of 80 and 1.08 of price. So when 80 goes up by 20% or down by 20%, we have the value actually yellow. We cannot see. Maybe I should choose another color. Let's say I'm going to choose green. So 80 goes up by 20%. 20% is 16. So it goes up by 20%, 96, and it goes down by 20%. That will be 64. Okay, so we actually have the presence of both 96 and 64. But now we have to look into the combination with the price. So when our price of 1.08 goes up by 10%, then the price becomes 1.19, and when it goes down by 10%, then the price becomes 0.97. First, when our demand goes up, so it becomes 96 and 1.19. Do we have it here? Yes, we exactly have it here, 96 and 1.19. So we just connect it with this one. Then when our demand is 96 and our price is down 0.97. Do we have it here? exactly, we have it here. So we just connect this line with this one, okay? And then in the next scenario, our demand goes down, and when it goes down, it is 64, right? It is normally 64. So we have to combine 64 with 1.19. Do we have it here? Yes, we have it here, 64 with 1.19. And then we will have to consider 64 with 0.97. Do we have it here? No, we don't have it here. So that's why we are going to add it, 64, 0.97. Okay, so our demand will be 64 and our price will be 0.97. So that's how we actually have, you see, we have 4 nodes for each of the nodes. So from this node we had 4 nodes, and then from each of these 4 nodes we had again 4 nodes. Okay, although we actually combine the presentation here with different nodes, when we will be doing a calculation, we actually calculate these 4, okay, these all the black 4 at once. The nodes with these lines, we again combine them for calculation together, and again this one calculation together, this one calculation together. So each of the lines representing the 4 nodes, we calculate them at once. We calculate them together when we are doing the calculations, and we do it separately. Although we present it together here, but we calculate them separately, okay? So in the next video, in the part 2 of this video, I will show you the calculation in Excel.